See this problem. A train sounds its whistle as it approaches and crosses a level crossing. An observer at the crossing measures a frequency of 219 Hz as the train approaches and a frequency of 184 Hz as it leaves. If the speed of the sound is taken to be 340 meter per second, find the speed of the train and the frequency of the whistle. Our motto is so there is an observer standing at the level crossing. So a train is approaching him. A train is approaching him by making a whistle. So that whistle's frequency is n. But the observer and the train is moving with velocity vs. But the observer standing at the level crossing hears about the frequency of n1. And after that the train is crossed him and it moving away, and still it is whistling. So its wave frequency is n only, but the observer will listen with frequency n2. Still the train is moving with the velocity vs. This is the exact situation. Now we need to find out the speed of the train. That means vs we need to find out, and the frequency of the whistle, and n is equal to what, that we need to find out. Those two we need to find out. That is our motto. Now I am going to resolve the and I am going to investigate the problem. What type of quantities that I have given. n1 is equal to 219 Hz, n2 is equal to 184 Hz, and v, velocity of sound, is given, that is 340 meter per second. Anyway, observer is at rest, so v0 is equal to 0. We need to find out velocity of the source and the frequency of the source. Now I am going to resolve the problem. So we already know from the Doppler effect that when an observer is at rest, the frequency, observed frequency n is equal to, n0 is equal to v by v plus or minus vs into n. Why I am using plus or minus? It depends upon the train's approach or source approach towards the observer. I am considering two cases here. So for example, n1 is when the source is approaching the observer. When the source is approaching the observer, v by v minus vs into n is the formula for the frequency, and n2 is equal to v by v plus vs into n is the formula for the frequency. Now I am going to substitute the given values. n1 is equal to 219 is equal to v 340, v is equal to 340 meter per second. So 340 by 340 minus vs we need to find out into n, and here it is 184 is equal to 340 divided by 340 plus vs into n. Now by readjusting or reshuffling these formulas, I will get two equations like 219 into 340 minus vs is equal to 340 n, and here 184 into 340 plus vs is equal to 340 n. If you divide these two equations 1 and 2, you will get 219 into 340 minus 219 Vs is equal to 184 into 340 plus 184 into Vs. So now I am bringing this Vs to that side and that numerical to this side. So you will get 219 minus 184 into 340, which is equal to 184 plus 219 into Vs. Now Vs is equal to, so 219 minus 184 will get 35 into 340 divided by 184 plus 219, 403. Now I am calculating this thing. Vs is equal to, using calculator, 35 into 340 divided by 403, that is 29.5. so it is 29.5 meter per second. So the train is moving with velocity 29.5 meter per second. Now I need to find out the frequency of the vessel. So I'll take any one of the equation from the above equations, that is 219 into 340 minus Vs is 29.5 is equal to 340 into n. So that implies n is equal to 219 into 340 minus 29.5 divided by 340, that is equal to, now I am using the calculator here, 340 minus 29.5 is equal to that much. That should be multiplied with 219, which should be divided by 340. 340 is equal to 199.99. that means it's nearly 200 hedges. So the train is approaching with velocity 29.5 meter per second and making a vessel of frequency 200 hedges.